Yeah. Good evening. Dear students, in morning session what I have done the class based upon electric flux and continuous topic I am doing, okay, related to electric flux only. Electric flux means morning already we have discussed. Electric flux is nothing but total number of electric field lines passes through the area of surface. That means whatever the area of surface is there, okay, in that area of surface, if the electric field lines are passing, means those number of electric field lines are called here electric flux. Now the topic is nothing but here Gauss law or Gauss theorem also. Okay, some textbook they have mentioned Gauss theorem also. So Gauss law, Gauss theorem, both are same. Okay, of course, in Gauss law, here we have to, what we have to study means, okay, what is the statement of Gauss law, and thereafter how to prove the Gauss law, thereafter applications of Gauss law. There are totally 3 applications are there in Gauss law. Those 3 applications, among those 3 applications, any one of the application is very important for 5 marks for your public examination. So first here statement has given, okay, Gauss law statement. Sir, what is the statement of Gauss law means? Okay, it states that the total electric flux through a closed surface, the total electric flux through a closed surface, the total electric flux through a closed surface is equal to 1 by epsilon naught times the total electric charge enclosed by that surface. Enclosed by that surface is called here, okay, that is nothing but here Gauss law. That means, sir, how to understand this Gauss law? Okay, statement how to understand, okay, I will tell. Now what he is saying means the electric flux. So electric flux is denoted by, morning I have told you, electric flux is denoted by, that is nothing but phi. Okay, right. Now thereafter, okay, electric flux, the total electric flux, that means the total electric flux is equal to how much ma? 1 by epsilon naught times of anta helidane. 1 by epsilon naught times of means, okay, times of total charge enclosed by the surface. Okay, he is saying enclosed by the surface. Okay, for example, if you take it here, now this is nothing but one charge is there, that is nothing but Q1, another charge is there, that is nothing but Q2, another charge is there, that is nothing but minus Q3, okay, another charge is there, that is nothing but Q4. Now like this, how many charges are there means, here Q1, Q2, Q3, okay, Q4, like this 4 charges are there. Now these 4 charges, another charge, of course I am going to take another charge also, that is nothing but here Q5 is there, that is nothing but minus Q5 is there. Totally how many number of charges I am taking here means 5 number of charges I am taking, which are Q1 charge, Q2 charge, Q3 charge, minus Q3 charge, Q4 charge and minus Q5 charge. 5 charges are there. Now afterwards what I am going to take here means, okay, in which how many number of charges are going to enclosed by a surface means some number of charges are going to enclosed by a surface. That means Q1, Q2, Q3, Q4, okay, these 4 charges are enclosed by a surface. Now this is nothing but whatever the shape I have drawn here, this is one of the surface, the name of the surface is nothing but Gaussian surface. What is that? Gaussian surface. Now around this Gaussian surface, we see within this Gaussian surface how many charges are there means plus Q1 plus Q2 minus Q3 plus Q4, but here minus Q5 is out of this surface is there. Okay, right. Now due to this first surface, due to this charge, charge means around the charge what will be there, electric field will be there. Electric field can be represented by electric field lines. So now due to this charge, the number of electric field lines, of course I can take like this. Now due to this charge, number of electric field lines I can take it as like this, right? Now from the positive charge, electric field lines are outward. Positive charge in the electric field outward away direction nalli irutte. Now negative charge, idu negative charge, okay, negative charge case alli number of electric field lines, okay, electric field lines inward to the charge, charge kadege irutte, ಇಲ್ಲಿ charge ಇಂದ electric field lines ದೂರ ಹೋಗ್ತವೆ. right? ಇಲ್ಲಿ ಇದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. Now for a positive charge, just look at here, electric field lines are away. Okay, now totally here due to discharge flux is there, here flux is there, here flux is there, here flux is there, right? Now thereafter the total flux due to these four charges, this charge we should not consider. Why? Because means this is not enclosed by a surface. Here clearly they have mentioned here. What is that means? Enclosed by this surface. The total charge, that means the total electric flux through a closed surface. Now this is a closed surface. Now the total electric flux through this closed surface is equal to 1 by epsilon naught times the total charge enclosed by the surface. Whatever the surface is, closed surface is there, within the closed surface whatever the charge is there, that charge only we have to take, right? Outside of this surface, if the charge is there means we should ignore it. Now thereafter total charge means, okay, let me total it. Okay, now total net charge means here we can take net charge, and thereafter next step I am going to tell here. Now flux phi equal to 1 by epsilon naught times of net charge means we have to add or subtract the charges according to their sign. Okay, first one is nothing but positive, so q1. Second one is positive plus q2. Third one is nothing but negative. Third one is nothing but negative, so minus q3, and fourth one is positive, so that is nothing but q4. Now like that we have to measure, right? Instead of writing all these charges with their signs, okay, we are going to put here, okay, q9. That means here according to the Gauss law, okay, mathematically Gauss theorem how we can write means, mathematically Gauss theorem we can write in such a manner, that is nothing but the total electric flux. You just observe here. Now the total electric flux through the closed surface is equal to 1 by epsilon naught times of net charge enclosed by the surface. Net charge enclosed by the surface. Now this is the mathematical expression of the Gauss law. Here whatever the situation is there, that means here net charge whatever there, okay, those are no need to write like this. Now this is only for your understand purpose I have written here. Okay, no need to, okay, write in notebook, right? This is the law, Gauss law, Gauss theorem, right? We are not going to any alter in this law. We are not going to change anything in this law. Whatever the law is there as it is, we have to write. Now this is right. Thereafter q net is nothing but net charge enclosed by the closed surface, and epsilon naught. What is the epsilon naught? Epsilon naught is the permittivity of the free space. Now about this I have explained to you in earlier class, right? Next, sir, what is the value of epsilon naught means? 8.854 into 10 power minus 12 Newton meter square per C. C is nothing but here Coulomb. Capital C we have to take, that is nothing but Coulomb square. Now this is the statement of the Gauss law. Now afterwards here proof of the Gauss law. Gauss law ಗೆ ನಾವು ಏನು ಬರಿಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕಂದ್ರೆ proof. Gauss law ಇದು ಕರೆಕ್ಟ್ ಆ ತಪ್ಪ ನಾವು ಪ್ರೂವ್ ಮಾಡಬೇಕು. That means phi equal to 1 by epsilon naught is equal to q net or q ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. Now to prove this one, that means for a proof of Gauss law, here what I am taking means, here I am taking one, okay, charge. This charge is locating at the right. Now you are observing here at the center here what I am taking means I am taking one positive charge. That positive charge is nothing but q positive charge I am taking. And thereafter you just look at here. Now here I have considered a sphere. Now spherical Gaussian surface I am imagining here. One sphere I am imagining Gaussian surface, spherical Gaussian surface I am imagining here. Now in this one, in this total surface here another one small surface I am imagining, right? Here one small, okay, surface on this sphere I am imagining. Right now this small spherical surface, okay, how it is being means it is looking like this, right? Now this is nothing but small area on this sphere I am considering. Okay, now you just observe here, this is the small area which I am imagining, considering on the surface, right? Sir, what is the area? That means here area has created. Sir, what is the direction of area means? Direction of area vector is always what we have to take, always normal to this surface. Okay, now for this surface normally perpendicularly we have to draw. So like this I am drawing. That is nothing but, okay, area. How we have to take? You take it a bar is a area vector, or delta s bar also we can take, no problem, right? A bar is a area vector. And thereafter, sir, what is the radius of this spherical sphere means? Area of this sphere is nothing but, here I am mentioning area of this sphere, sorry, what is the radius of this sphere means? Radius of this sphere, here I am giving, that is nothing but r. That means from this point to point origin, from origin to, okay, on to this surface, the radius is nothing but what I can take here means, I can take here, that is r. And thereafter, this is what type of charge? Positive charge. Sir, around any one charged particle, what will be exist means electric field will be exist, right? Electric field can be represented by electric field lines. Suppose if the charge is positive, electric field lines are, we can draw outward. If the charge is negative, electric field lines are, we can draw, okay, inward to the charge. Now we just look at here, okay, this is the positive charge. Now from this positive charge at a point, at this point, on the point P, that means at point P, the electric field vector direction is, okay, radially which direction means outward direction, that direction I am representing here. Now here only A vector direction is there, here only E bar vector also is there. Now thereafter, let me have the concept here. Now from this one, from this diagram, okay, I would like to write something. Sir, what is the, this is the small area I am taking, so small area name is nothing but here delta S bar. Delta S bar is nothing but small area which we have considered on this sphere. Now from the, by the definition of flux, right, by the definition of flux, what we can write, let me see here, electric flux. What is the definition of electric flux? Morning I have explained to you. Okay, the definition of electric flux is nothing but E bar dot delta S bar, or E bar dot A bar also we can take. Right, that is nothing but E bar dot we can take delta S bar. Right, now thereafter, okay, flux for a small area, flux also very small. So delta is represent small. Right, small flux delta phi is equal to, I can write here E into delta S I can write. Since, why? Because in bracket I am mentioning here theta is equal to 0. Sir, which theta is equal to 0? Actually this one we can write E bar dot delta S bar is nothing but E delta S cos theta we can write. Cos theta we can write. Dot product means cos theta. Cross product means sin theta will become here. Right, E delta S we can write. E is nothing but electric field, delta S is nothing but, okay, area. And thereafter you just see here cos theta, cos 0 degree is nothing but 0, so we may get like this. Right, now thereafter, sir, E delta phi is equal to, here we can write E bar delta S we can write. And thereafter E is nothing but electric field. Right, electric field due to a charge is nothing but at any distance r. We know that electric field due to a charge at any distance is nothing but, the formula I have derived is nothing but 1 by 4 pi epsilon naught q divided by r square. R square is nothing but distance from charge to considerable point. Okay, q is nothing but whatever the charge we are having here. Okay, now here you take it as, this is nothing but equation number 1 and this one is nothing but equation number 2. Now from equation 1 and 2, see what we may get here. Right, from equation 1 and 2, right, what we may have here, you just look at here. Right, delta phi is equal to, here I am having E is nothing but 1 by 4 pi epsilon naught q divided by r square into what I can write, delta S, as it is delta S. Q value I have substituted here. And thereafter, here delta S is nothing but small area on the okay, sphere. Like this, we may consider here some number of areas. In that case, okay, the total electric flux, that means summation of, okay, all area of delta phi is equal to, we can write 1 by 4 by epsilon naught of, right, summation of, right. Now like this, here only one element is there, ma? Only one element is there. Here also you can imagine another element. Here also you can imagine another element. For this element, okay, phi equal to 1 by 4 pi epsilon naught q divided by r square. Like this, if you consider another means another delta phi you may get. If you consider another means another delta phi also you can get. Now summation, that means all delta phi's we have to make it summation. Right, summation of all the elements of delta phi is equal to, we can write summation of, okay, all the area of, we may have here 1 by 4 pi epsilon naught q divided by r square into delta s, of course we can write. Now from this one, here we may write, okay, this one is nothing but total flux, means we can write capital phi is equal to, thereafter 1 by 4 pi epsilon naught divided into q by r square of summation of all the area. Delta S means all the area. What is the total area? That means all the area of the sphere. What is the total area of the sphere? Is nothing but 4 pi r square, which is, so phi is equal to, here we are having 1 by 4 pi epsilon naught q divided by r square into total area of the sphere. Now this one is gives total area of the sphere. What is the total area of the sphere? Means 4 pi r square area of the sphere. So here is that. Right. What are the terms are going to cancel here? 4 pi r going to cancel, and thereafter r square is going to cancel. Right. The remaining terms are nothing but here. Okay. Phi is equal to 1 divided by epsilon naught into what we are having here? Only q. That means total flux through this closed surface is equal to, if you just see here, total flux through this closed surface is equal to 1 by 4 pi epsilon naught into q. We are having. Now this is the statement of Gauss law, and it's so proof, right? Yes.